Hello and welcome to our next session in our course on using information theory for analysis of complex systems. In this session, I'm going to give you an introduction to the JIDT open source software toolkit for using information theory to analyze complex systems. In this first short video, we're going to start with an overview of JIDT. For the session itself, there are several learning outcomes I'd like you to take away. Firstly, to understand what JIDT offers for information theoretic calculation, what kind of measures we have and what kind of estimators there are implemented in the toolkit. I want you to be able to obtain and to install the distribution of the software and to be able to use our special auto analyzer GUI demo to be able to make simple information theoretic calculations on discrete data. We'll look at continuous data in our next session. Finally, I'd like you to be able to understand how and where to seek further information on the toolkit. The primary reference for this session is the paper introducing the toolkit, which is packaged with the software. We'll have a brief look at that later on. Okay, so JIDT provides a standalone open source software implementation of information theoretic measures of how information is processed in complex systems, focusing in particular on measuring how information is stored, transferred, and modified. The software is open source licensed using the GPL version 3 license. It includes implementations principally for transfer entropy, mutual information, and their conditional variance, as well as active information storage for measuring the storage information, and so on. It's usable for both discrete and continuous value data and provides a range of implementation of different kinds of estimators. So not only estimators for discrete value data, but for continuous value data, for example, using linear Gaussian models or the well-known Kraskov estimator. The toolkit is available on GitHub. I'll show you the website there briefly. We will look at it in more detail later on. Okay, so the J in JIDT stands for Java, and that's because the toolkit is written under the hood in Java. That doesn't mean that you have to use Java to be able to use the toolkit though. It's directly usable in MATLAB and its open source clone Octave. It's usable in Python, as well as in a number of other languages. We'll focus on Java, MATLAB, and Python here. Importantly, it requires almost zero installation for you, so that's a very low overhead for getting started. The software is distributed with a paper describing its design and usage. It's distributed with a full tutorial and exercises, as well as a much longer course, which is in progress for development, and this video is a part of that course, as well as full Java docs, which document how to use the calculators, and a suite of demonstrations, including in each of the languages listed above, and in particular, a GUI or graphical user interface application to allow you to perform push-button analysis using the key measures that are implemented in the toolkit, as well as to generate code templates to extend later on. The credits for the software go to myself, as well as some more recent collaborators, including Ipek Özdemir and Pedro Mediano. Others are currently contributing to the software and will be listed on the website once that goes live. And I hope to encourage more of you to contribute in the future too. So why should you use JIDT? Well, I believe it's unique in the combination of features that it provides. It offers a very large array of measures, including all the conditional and multivariate forms of transfer entropy, mutual information, so on, and complementary measures such as the active information storage and excess entropy, and so on. Not only is there a very wide range of estimators, a very wide range of measures implemented, but we have a wide variety of estimator types available for each of our measures as well, and these are applicable to both discrete and continuous value data. So that can be used across many different domains. As of version 1.2, we have a table showing which measures we have implemented and which estimator types we have implemented for each measures, and you'll see that we have a very wide coverage there of the measures and the estimators that are implemented for them, and that is growing with time as well. This is valid as of version 1.2. There are more of those ticks in the table filled out now, and more coming as well, including we have some new measures coming online soon for the partial information decomposition. So why should you use JIDT? Again, this comes back to what I described as its features being unique in the combination of implementations provided. We have a very large array of measures, as I mentioned already. We have a very wide variety of estimator types for these measures. Not only that, we offer local measurement for all the estimators, which is very useful for studying the dynamics of complex systems. We include statistical significance calculations for our measures of commonly held information like mutual information, transfer entropy, and their conditional variance. I mentioned before that it's a very easy toolkit to install. There are no dependencies on other installations except for having a Java virtual machine. There are things that you can install to extend the functionality, and we'll have a look at those later on. There are also lots and lots of demos and information available on our website and wiki. Let's flick over to that very briefly to have a look. So we've already seen the homepage, of the GitHub page here, showing the code and the landing wiki page, where we see a plot of a figure of the graphical user interface demo. If we dive into the wiki over here, we'll see there's a lot of pages here showing you things like how to get started, what kind of demos there are, and talking through those, as well as looking how to get it running in non-Java environments, and so on. We'll go through some of these pages in a bit more detail later on. Additionally to the demo, or as one of the key demos I wanted to highlight, was the Gui Tool, the auto analyzer, which we'll be looking at in far more detail later on, which I think is a very important component of the JIDT software, because it gives you a graphical tool for easy calculation of the primary measures here. You can calculate transfer entropy on a given data set without writing any code at all, just by pointing the mouse and clicking some buttons and filling in some parameters. Not only can you calculate the values very easily, you can use that Gui tool to generate code templates that you can extend very easily if you want to do more complicated things. Finally, as part of our introduction, I'd like to answer the question I often get asked about why is the toolkit implemented in Java instead of something like C on one hand or Python or MATLAB on the other. There's a few reasons for that. For me, Java provides a very good compromise between C on one hand in terms of performance, and MATLAB and Python on the other hand for ease of use. That compromise is in terms of giving high performance that's comparable to C. It's probably only 20 or 30% behind C, rather than orders of magnitude behind, as the easier to use languages like Octave, like MATLAB, Octave, and Python are. Yet it's platform agnostic. It's very difficult to distribute C code across multiple platforms. That's not the case with Java. We just require a Java virtual machine. With that, we can couple that high performance with object-oriented code that's very easy to write. It provides us a hierarchical design for interfaces for each measure that allows us to dynamically swap different estimators for the same measure at runtime. So we could analyze the information transfer between two brain regions from, say, an EEG dataset, first using a linear Gaussian estimator. Then at the change of one line of code, we can do that with a much more complicated estimator. And that sort of dynamic swapping is very, very useful for us in our experiments. On top of that, the toolkit can be called directly from these easier to use languages. So while I've implemented in Java, you don't have to write your code in Java to be able to use the toolkit. You can call it directly from MATLAB, Octave, Python, and a range of other languages. So we balance high performance with ease of use. You can still write your code in these very easy to use languages and obtain all these benefits of performance underneath the hood. Finally, we get automatic generation of Java docs. I'll show you those later on. They allow you to see all the fine detail that you need to understand the different methods that you might be calling down the track. In our next short video, I'll start to show you how to install the toolkit.